sorry, I'll just start recording. Yeah, so I don't think that this much of the things are really that much important, so the hand-on practice begins here. So I'll just copy this code from here. So I'll just go to my terminal. So there are some few commands like cd documents to go to the documents folder in your main this type of directories. So when I click here, it will go to the documents folder. Now what I can do is just go to what I can do is just go to this line and write git version. So it will show me that I have the git version 2.52, which means the git is working properly. So before, if you have not downloaded the git, if you will write this thing, it will show you some error. And if you have successfully downloaded the git version, then it will show you the version of git. Now the simple thing is you have to just write git clone and you have to paste that link here, and it will just, and press enter, it will just clone the repo. It has cloned the repo very fastly because we just have one more, file in it. So when I go to my folder, documents folder, so you see I have this third AGN school here. So I'll what I will do here, I'll just make it enlarge. So now what I can do it, I can go to third agent school folder. Now there is a command which is not known as make dir. So this is the command which helps you create a folder inside a folder. Okay, so basically we will create a folder as day one. Okay, so when I press enter, you see day one folder has been created here. So now what I will do is I'll go to the I'll leave this here for now. I'll leave this for here, and now I will launch Jupyter Notebook. Okay, so you have two options. You can either work on VS Code, or you can download Jupyter Notebook. So Jupyter Notebook is also kind of IDE for the this Python data analysis. You can either work on Jupyter Lab or Jupyter Notebook. Throughout this course we will be working on Jupyter Notebook, so I'll just share the link with you. You can just go to jupyter.org. I hope most of you guys have already yes, this works for Windows as well. So Rafal, this works for Windows as well. So you can just download it on GitHub, and the command line codes are same for Windows as well. So you can I hope most of you have already downloaded the Jupyter Notebook if you are working in data analysis stuff already. So we will be working in Jupyter Notebook right away. So we have option to work on VS Code, but it is not that much visually good to analyze graphs and all that stuff. Okay, so we will be not using VS Code. So I have to open the Jupyter Notebook in this folder. So I have just came to this folder like cd third agent school, and now I will just write here Jupyter Notebook. So you have two options now. If you are working on the Mac, you can just directly write Jupyter Notebook in the directory here and press enter. It will directly open. It will take 1 or 2 seconds and directly open the interface to you. The another option is for the Windows. You can just go to the start menu and just manually type Jupyter Notebook and click on it, and you will have the interface open for the Jupyter Notebook. Okay, so it will take few time like, yeah, you can see that it has been here now. So I just opened the day one folder, and you might not see these many options. You might see only these options. So these are for Julia language. You can also work on in Julia in Jupyter Notebook, and these are some more environments I have created for my personal work. So I'll open the Glamo one. I already downloaded all the libraries in it. However, I will make sure you also have the same stuff with you. So I'll just name it as day one. Okay, so this one is basically the rough kind of thing. We will be doing everything from scratch. However, I'll share a book with you, and a reference material with you which you can work upon, and you can do practice in for with that material. The thing is, I just closed that home tab. So now I don't think my Jupyter notebook will work. I have to just go through once here. I'll relaunch it. Just a second. Okay. Okay. So I just opened it. Now we will start with the basic Python. So first of all, we will learn how to write the command line functions. Okay. So how to write a markdown functions, how to write markdowns in Jupyter notebook. So you have to just either escape this and click on M, or otherwise you can shift the things from here, from code, raw, or markdown. Right now I will go to markdown. Day 1 of third AGN school. So when I will press shift return or shift enter, you see it is a big heading with day 1 of third agent school. So there are some functions, there are some syntax, like if you press double hash tag, and then you will write day 1. Okay, day 1, and then you will go with these 3 hashes, and then you will go with 4 hashtags, and then you go with the 5 one. However, I don't think that much works. And there are some commands like bold, which we have similar in HTML language. So day 1, then we have I for italic. So these are basically to make your this notebook look organized and beautiful. So these are some of the commands. So these are some of the commands we will be using for segregating our stuff in the Jupyter notebook. Okay, so right now it gave the error because I have not shifted the cell. This is known as cell to the markdown. So when I will shift the cell to markdown, and you can see here. So another thing is, you can just go with BR to shift to the next line. Okay, so you see italic, bold, and these are some of the fonts you can use. Okay, so there is something called so I just went again to the markdown and just apply 2 hyphens, and when I will 3 hyphens, sorry, when I will shift press, it will create a line here. Okay, so these are some of the functions, these are some of the syntax you can use in the command lines. Okay, so these are some of the basic and the playful stuff you can do. You can even change the colors and all that stuff. That actually went to the HTML language, which we are not really into right now, because we have to focus on astronomy, right? So first Python command line. Okay, so it's a very famous command line. We have to ask computer to print something, okay, in using Python. So whenever we have to ask our computer to print something in Python, we have to write print, then parentheses, then these inverted commas, and then we have to write like hi astronomers. Okay, so then I'll press shift enter, so it will print hi astronomers. Okay, so this is the basic command line to print something in Python. Okay, so we will be going through all the basic command lines. So we will be covering print, input, output functions, and then we will be covering complex print syntaxes. Then we will be covering loops, indexing, slicing functions, all that stuff, and control syntax like if and else. So however, one of the most important thing is functions, that we will be dealing all through our course. Okay, and even in astronomy we create a lot of functions. So right now, if I just go to another thing here, so welcome to third AGN school. So you see, it works something like this. Okay, so even I can print a number. Okay, if I just print this here, so it will print that number. Okay, so there are something called variables. We will be discussing about them in future, like in a few minutes. There are something called variables. Variables are of different types. We will be discussing later. Now there is a command known as formatted printing. Formatted printing is a type where we can mix or many things to print something. Okay, so for that, before that, there is a simple thing. This is a comment. So this is a comment when we write hash in the code, not in the markdown, and then write something here, it will not be executed. It will just remain like this. Why it help in Python? Like I write here something. Hi everyone, and here I just write this is a print syntax in Python. So only hi everyone will get printed, not this is a print syntax in Python, right? So this is really helpful when you are writing a big pipelines and code and functions in Python for your astronomy data analysis, and it helps us to get really into that specific part of the code which we are supposed to see. Okay, so let's go to variables now. Variables. I'll write markdown here. So you can just click escape and then go to markdown. Okay, so your cell will be shifted to markdown. Okay, so there are some few features here. You can change the theme from light to dark or high contrast. So you can even download your this notebook in the form of HTML, LaTeX, or PDF, and many other formats. So there are variables. So let's, as the name suggests, variable is something which we will be assigning some value, which are variable, which can be anything, right? So let's say A is equals to 1, B is equals to astronomy, then C is equals to, okay, so it's in markdown. First I have to change it. So okay, so and then C is equals to true, D is equals to 26.9, let's say. Okay, so these are major variables. So now I will be using comments to let you know which type of variable is this. So this is a integer, this is a string, this is a boolean, this is a decimal. Okay, so one more thing, a decimal is a integer, but an integer is not a decimal. Okay, so when I execute this cell, you think nothing happens because we have not given it any command to print anything or for any output. We just have assigned some values, that A is equals to 1, B is equal to integer, and C is equal to true, D is equal to 26.9. Now you see here, for a string we have given these inverted commas here, and then we have to write some name here. So string is something which comes inside the inverted comma, so you can write anything. So it's like some alphabet. Okay, alphabets. However, you can even write 1 2 3 here, but it will be string when you are writing inside these kind of things. Okay, so now there is something more about the comments. Okay, so I will add here only. So when you have to write multi-line comments, okay, so this is a multi-line comment. So maybe you have to write a long big line. Okay, so you can use these type of things here. However, I think this might not be, yeah, might not work in Jupyter notebook, but it works in the VS code. uh, Actually, why this do not work in Jupyter notebook is that because even if you write print or not in Jupyter notebook, it will execute your command. Let's say I'll just write hi. I'll just go with this hi astronomers. Okay, astronomer. It just print your command. So this is the default feature of Jupyter notebook. But you can just keep in mind that if you have to write multi-line command in some another IDE you are working in future, then you can use these type of things. Otherwise, you can do write multiple hashes, as this is first line, then this is second line. So this might be also useful. I use most of the time, I use these type of things. These type of multi-line comments are used when I'm working in some another ID, but my most of the work is done in this Jupyter notebook only. Okay, so there is one more thing now to discuss here. I'll just go escape and add a cell here. So maybe you are working with some grammatical English. Okay, so when you are working with specific type of grammar, let's say when you are, even if you go with a single inverted commas, it will work. Hi everyone, it will work. Okay, so but there is an issue here. Okay, so you can just go to escape and then press B to add the cell here. So then when you are working like he is an astronomer, it will print an error. Okay, so while dealing with the single inverted commas, it only consider he as its value, as string, and rest of the part it doesn't consider as a string. Okay, that's why it gave an invalid syntax error. So what we have to do is, in the case of these type of words like he, wasn't, I'll, and these type of short mnemonics, we have to use double inverted commas. So this line whole will be now a string. Okay, so this will not give an error. However, I will paste this error here so that this remains in your mind when you go through again this PDF, this notebook again. So yeah, this is the correct way. This is a correct way to deal with short shortcuts, let's say. Okay, so now we will deal with the formatted printings. Okay, so formatting printing is very much used in astronomy basically. So we don't use these type of basic print values in astronomy because we have some values to show in the output. Okay, so we have to mix all these functions. Right now it's only printing a string. Okay, so when we need to print maybe a integer plus string plus a boolean plus something decimal in one sentence, so how will you do? So let's say I just assign a new variable name as star. Star is equals to, star will be a name, so it will come in the parentheses in the inverted commas, let's say vega. Okay, and distance will be something decimal or integer in some units. I don't know right now a specific distance, so let's say 8.6 units. Let's see, I'm just doing a random guess. Now to print both vega and distance in one sentence, we have to use something called f string. Okay, so f string is used here. So what I will do is I'll write f string formatted printing. Okay, so let's add one more. Okay, so yeah, so you have to use f here, and what you have to do is now you have to go through these curly brackets and you have to write star. Star here, you have just see what I will do and then I will explain you. Okay, star is this much distance, exact word of the variable. Okay, so light years away. So you see here, when I executed this command, it shows Vega is 8.6 light years away. Okay, so you see, when I write something in curly brackets and assign the name of the star Vega, assign the name of the variable, that is star, and then I have assigned the name distance, so it just go to that variable and check the value for that and just put it here. Okay, so it will what will be the output? Basically, Vega is 8.6 light years away. Okay, so this is how these type of things work, and we use when we are calculating some velocity dispersions or these kind of things. So we assign those variable in the print command so that we can get the velocity dispersion for the specific galaxy or something. Okay, so similarly we can do one more example. Let's say the planet. Okay, so okay, so any doubts till here? Any doubts? So I hope this is very going very simple right now. We haven't done any Python yet. So okay. So if you have any doubt you can just ask. Okay. So let's say Mars, planet's Mars, and then radius. Let's say 4,000. I don't know the exact value. Okay. So I'll go to print. Then I will, before the inverted commas, I will write f, and then the radius of the of planet. So here it will put whatever the value of the planet is. So it's Mars, so it will put here Mars is radius kilometers. So the radius of Mars is 4,000 kilometers. This is one more example of same type of format printing. Okay, so there is something this will be used a lot in our future astronomy analysis. So these kind of formatted printings. So now we will go to the input and output functions. Okay, so input and output functions. So basically these are not used much in astronomy, but for the sake of knowledge you must know that this type of thing exists. If you get some problem in which you have to use these type of things. Okay, so let's say we assign, taking a simple and very basic example of input and output function, we will assign a variable in which we have to ask someone enter your name. Okay, so we have to initially write input. So input is something that we will be going to ask, and then we have to write then parentheses and then inverted commas, we have to write the messages in the form of string. So what is your name? Okay, so then what I will do is print, then I'll use a formatted printing and welcome and then name. Okay, so when I will press shift enter, you see here it is showing a star, not the numbers like 18, 17. Why it's showing the star? Because the kernel is busy. So when I hover to these type of dot here, it shows that the kernel status is busy. There is one cell to be executed and total time it has taken right now is 19 to 20 seconds right now. Okay, why it's busy right now? Because we have to write our name or any value in it. So I'll write Jashanpreet here and then I will press enter. So you see it prints the value welcome Jashanpreet. Okay, so this is the input and output functions. So similarly you can ask the name, or you can ask any value. Okay, so there is something one when you are like asking for the age or any quantity which is an integer, so there is a chance that you might not get always an integer as input from the clumsy user. Okay, so when you have to ask for an integer, you have to write int here. So int is int will make sure that all the quantity entered will be integer. So what's your CGPA? So let's say we are asking for CGPA. Okay, so what's your CGPA? And okay, I know it's a weird question, but okay, so uh, just print. So just print nice. Okay. Uh, this will be only printed if there will be the enter. We will enter some kind of integer. Okay. So I have missed here. The technical name for decimal here is float. Okay. Float. Okay. So you can also change it to float. Okay. Float or integer. Float will help much more, because if my it might be possible that your value is in the decimal quantity. So when I run this, let's say I'll write my name here, so it will give an error because it say the string couldn't convert string to float, because then it try to process your input and it sees that it's a string, not a float entered. So when I rerun this program, and let's say I write the CGPA like 8.7 here and just rerun this, enter this, couldn't execute due to pending. Okay, so yeah, I just press shift enter. I'll just have to press enter here, so it shows nice. Okay, so these are some of the examples for the input output function. However, we don't use haven't used this so far in astronomy data analysis, but this might be useful in some rare cases. Okay, so yeah, so we dealt with these kind of things, variables. Okay, so you can even check the variable type. I'll copy the cell and paste it here for the sake of easiness. And now we have something called type, and then I'll write a variable name. Okay, so there are some things before type. I have some thing to tell you. So when I will write print a, and I'll write print a, so there is a difference here. There is a big difference here. So anyone in the comment section who might able to tell what will be the answers and output for both of these quantity. Okay, so what will be the output for #1 case and #2 case? So please, anyone in the comment section. So yeah, the first case is in which we have written the A, letter A, and the inverted commas, and another one we have just wrote A. So it's very simple. So yeah, for the first case it will be A, as per Sophia, and for the second case it will be 1. So yeah, Sophia is right. Why? For the first case, it's considering the input as a string, because I told you whenever something is written in inverted commas, it considered as string, so it will be going to print A here. So in the second case, we have not written a string or something here. Okay, we have just print A. So for this case, it will go and search for something, some variable named as A. So it will search here in the cell, and it will see A here, and it will print the value of A. Okay, not A here. So this will print the value of variable A. Okay, so you see, when I executed this command, for the first it says A, and for the second it's print the value of the variable. When I go to B, you see it shows a value of B, and similarly when I go to these type of things, so it shows different values. Okay, so I'll increase the number to like this quantity, and you can see the difference. Okay, so there is a syntax to check the type of these type of variables, different variables. So when I write type, uh, okay, so I think we might not be able to start NumPy today. Okay, so we will do it together with the matplotlib and other stuff. So it will be easier to grab also, because NumPy array, we have to deal with NumPy arrays, which is closely related to the data analysis stuff, and we will do all that data analysis stuff together with all these libraries like NumPy, Pandas, matplotlib tomorrow. Okay, so today we will be trying to cover most of the important basic fundamentals of Python, okay, which we will be using in future. So when I will type this command, type, and then parenthesis, brackets, and then this x, in the terms of x I have to write a variable name. So you see it shows the type integer. Okay, when I go for the B, it shows string, str. So similarly, when we wrote here float, we can write int, and for specifying that we only need a string, you have to write str, not a full word string. You have to write str. For the integer you have to write int, and then for the float we have to write float. Okay, similarly you can check value type for C, it will show bool. For boolean, it is a short name, and for D it will show the full name float. Okay, so this is how you can check the type, D type, so data type. Okay, so which type of data it is. Okay, so then we have something called arithmetic operators for doing mathematical calculations. So there are two type of operators, actually three type of operators. So we will be dealing all of them. Operators. So we have number one, arithmetic operators. Then we have comparison operators. Then we have another logical operators. So in this in these type of operators, we have like plus, minus, multiply. For multiply we use this asterisk mark, and then we have the divide, then we have the remainder, and then we have this modulus here, and then we have the raised to power. Okay, so the power sign. So in the comparison we have greater than, as the name suggests, then we have less than, then we have equal to, exactly equals to, then we have not equal to. Okay, so we also have equal to, greater than equal to, or you can say, and equals to, less than, something like this. So for the logical operators, we have the three operators: and, or, not. Okay, now I'll just convert this to command line, so to the marked up, sorry. So you see these are all here. What I'll do is I'll just make them bold. Okay, so I told you how to make things bold in markdown. Okay, so I'll just do the same here. Okay, so yeah, now it will look nice. Okay, so we have these type of operators, so let's first deal with arithmetic operators. Okay, so arithmetic operators, so let's say we have two values, a is equals to let's say x is equals to 10 and y is equals to 2. So now what I will do is just I will write prints, a lot of print now, to show you how these works. So I'll just copy this print here, then I will write x plus y, then I'll just change the values here, x minus y, then I will write x multiplied by y, then I will here write x divided by y, then these type of things, then modulus, then raised to power. So you see here that this is addition, add, this is subtract, this is multiply. So I'm sure that you will be getting might be getting bored today, because we are doing very fundamental stuff. Okay, so this type of knowledge of Python till PhD or MSc level, all students have this much level of knowledge, but for the creating fundamentals, for the further complex stuff we will be dealing in a few next days, we need these basic things. Okay, so this is division, and then we have quotient, and then we have remainder, then we have power. Okay, so these are the things, these are the values. So now let's go. So it's easy, I don't have to explain it much, right? So it's very easy. So this is just simple calculation, so calculated stuff. Okay, so now let's go to the comparison one, comparison operators. So I'll change this to markdown as well. Okay, so for the comparison operators, the output will be either in true or false, because when we are doing comparison, it is either correct comparison or it is false comparison, right? So let's say 10 greater than 5, it's a true. Okay, similarly what we can do is x greater than y, it says true because we have assigned x as 10 and y as 2. Okay, so why it printed true? Because either x is greater than or equal to y. This means something like this: either greater or equal. Okay, but when I will do x less than equal to y, it says false, because x value is 10 and it's not less than y, that's 2, and it is neither equal. Okay, so either less or equal, x equals to y, it will be again false, because exactly equal. Okay, so then we can use these as single: x greater than y, x less than y. Okay, so these are some of the functions, syntax. So these are some of the basic things. We use logical operators a lot. Okay, in when we are writing kind of a loop or a function in which we have to write if-else statement or loops, we use and or not also. So let's take an example. Let's say we have temperature, temp is equals to 6000, and we have to just print something. Let's see, temperature greater than 5000, and I'll use and here, less than 7000. So the output will be true. Why? It will be printing boolean values, that it's saying that temperature value is greater than 5000 and less than 7000. Now I have some more things here. Let's say I just go to or is greater but less than 1000. So it again print true, because yes, it's greater than 5000 but not less than. Either of these terms can be true. Okay, so something we can use here, not sorry, we have one more choice, I'll show you. Then we will deal with not. So there is a syntax error here, so I'll show you why that has come. So let's say it's greater than 7000, okay, and less than 1000. So okay, so where's the error? Okay, so I have not written or. So you see, neither of these things are true. Okay, so this is how we can use or and or not. I'll show you how to use not. So however, we don't use these type of statement in astronomy data analysis. The real statement are more complex. Okay, so to use not, so not will actually make your answer reverse. Okay, let's say t is equals to true. So there are two things. Now I have written true here. It is an invalid command. Okay, so when you have to write boolean, you have to make sure that the first letter is always capital. So now it is assigned as a boolean. Okay, now when I will print here that not x, not t, or not because x we have already assigned, so not t, it will show the opposite. Okay, so not doesn't work like these type of things, so it works actually opposite to the result. Okay, so these are as the name suggests, these are kind of logical operators. Okay, so how the logical operators work, just like logic gates, you can say. Okay, then so we are covered with a little bit. Now I'll create a line here. So till now, do anyone have any doubt? If not, you can just give me a thumbs up. So yeah, okay. So I think no one has any doubt because it's very simple, right? So now what we are going to do is very important and very much used in astronomy data analysis, very much. So you have to keep in mind the concept we are now trying to do, because it will be used a lot, a lot. Okay, so it's named as indexing and slicing. Okay, so when we have fits file, most of my, you know, the fit file contain different tables. Okay, in those table we have different parameters, different columns, different matrices. Okay, so we might not use whole of that fits file, but might use a single table or a matrix from that table. So to slice or to grab that particular table from that part of the fits file, we use slicing. So slicing is basically a type of indexing. So as the name suggests, slicing is something we are slicing into. So basically we are slicing a part of a huge data to work on that small data. Indexing is something known as place value. In our primary school or secondary school, we have done face values and place values. Place values is a value in which that particular type of value inside that particular matrix is contained. So I know I have spoken a lot right now. It might have messed you, but I'll just show you now. So what I'm talking about. But this part is very important. Okay, so we are done with the basic Python. These kind of this is actually kid Python stuff. Okay, for a kid. So now we will be learning something a bit intermediate. Okay, so let's say we have a star named Sirius. Okay, Sirius. Now I have something to tell you here now. So we have the word S, which is index 0. Then we have word I, which have 1 index. Then we have R as 2 index. Then we have a letter I, which have the third index, and then we have U as fourth index, then we have S as fifth index. So these are the place values to those letters. Okay, so you must remember that the indexing start from 0, not 1. The counting in Python starts from 0. Okay, so when you have to slice a particular part, let's say I have to print something that is indexed at 0. Okay, so this is a very short data. So this data is only 5 quantities, 5 indexes, but fits file contain lakhs of columns, 10,000 columns. You might don't know that at what place value your data is contained, or you might know that at that particular place value our data is, so we have to grab that data from that particular value. So let's say we have to grab just S value. So how will I do that? I know that S is contained at the place value 0, the one S we need, not the last one. Okay, similarly, one more thing to show you here, that if we go to if we go and reverse, then 5 is also known as -1, 4 is also known as -2. Okay, then 3 is also known as -3, not always, depending on the length. Okay, so -4 and -5, -6. Okay, so you can also use any one of them. So you might know that from the last values my number is this, but you don't know from starting where it is. Okay, so it might be on second last or third last or 50th last. Okay, from down. Okay, so now how to print. So basically you have to do print, and then you have to write variable name, then you have to write box bracket, okay, square brackets, then you have to print write the index value, and when I will press shift enter, you will see it will print S. And similarly, when I will write -6 here, you see it again print S. Okay, when I will write -5 here, it print I, because -I is a value for I. Okay, so this is what is indexing. However, we will be dealing with indexing in future in very complex way, so this is only basic indexing you must know for now. But however, we will deal right now with the slicing in very much detail. Okay, now okay, so okay, let's say we have again a star. Okay, see this. Now slicing is, indexing is a part of slicing, right? So we are even slicing here, but we are just slicing a specific letter. But what if we need first three letters, or middle three, or these type of some part of the data, right? So what we'll be using is, so index will remain the same. What will be the command here will be star, then bracket, then from 0 index print till third index. So you see it will take the first letter 0 index, 1 index, and the second index, but it will not print the third index. Okay, so there is a very important shortcut to remember, that will be print. So inside the slicing works like start, stop, skip. So this is the keyword SSS. So it will start from 0, it will stop at 3, but will not contain the word 3. Okay, so it will not print the word, the value at third index. Okay, so we have not assigned any skipped value, so it assume that there is nothing to be skipped. Okay, so I'll just do one more example here. Start, then start from 1, skip the 0 index, and until the 0 1 2 3 4 5 fifth index, and skip 1. Okay, so now you see what it has done is it will print the 1. Okay, so okay, so now here is a problem. Okay, so here is a problem, not a problem. Mm, so it is basically a default thing here. To skip one value, like we have to skip uh, r and then u, we have to write that 2 here. Okay, so that because it assume 1 as I, because whenever it start from a specific index, it considered is as a first value. Okay, so don't mix that with the index values. Index always start from 0, but when you are like getting into the skipping part, the thing starts from 1. Okay, so you have to print the first index value, and then you have to skip 1 here. So it will say that I have this is my first value, there is no second value skipped, so it will print the another value, and then again and again and again. But when I will do 2 here, so you see it only print I, because it considered 1 as I and then another as 2, and it skipped the second value, and then it consider another value, that is the next value I, it make it as the first value and skip the another value, and we know that it will never print the last value. Okay, so wait a second, so here it is. So if I just delete the fifth index and then print it all, it will also print I, because it will consider s as the first value again. So it will assume that it have to print all of the values. Okay, so these are the things you can play around. So similarly, if I just want all of the word series but with the one letter skip, so you see it write SRU. Okay, so these are the things. Let's skip the I value and then print R, and then print another I value, and then print U, and then it skip the S value. So these are the things. I hope that you don't have any issue in slicing as well. So this is what slicing is all about. So yeah. So we have a little more complex slicing, the slicing of matrices. When we have this is actually 1D data, right? So when we have 3D data or 2D matrices, or 3D matrices like 3 cross 3 matrices, we have to do slicing. So we will deal with that type of slicing in NumPy, or when we are dealing with the Astropy. So that will help more to visualize, because when if you will I will teach you now, you might forget at that point of time. So we will be doing that thing while we are discussing the astronomical data analysis, so that you can also get the recap of what we have done earlier. Okay, so now we will be dealing with Python lists. Okay, so yeah. um, so list is basically a thing to store multiple values. Okay, list store multiple values. So you can store any values from strings, boolean, float, or any integers. Okay, so just a second. Let's say we have this list name. What I should name it? So let's name it a name list. Okay, so for a list we have to write it in a box bracket or a square bracket. Then we have to assign that let's say first letter is earth, first quantity or element in the list is earth, then let's say any number, and then true, then another number 1.1, and yeah, so this is our list. So okay, so let's make it short, like name. Okay, so this is a list, this is our list. Okay, so now we have to do the slicing of list, so we have to basically practice that. So print name, and then we will use index. So let's say print everything, just skip the second value, so it will print the first value, then skip this, and then print this value, and then skip this. So this is how the slicing work. Or maybe I can just print the first value 0, so it will print earth. Okay, so what I will do is I'll try if it work like this. Okay, so that doesn't work like that. So basically I just want to show you that if we do slicing of a list, it's again a list. Okay, so this is how it works. Maybe it worked like, I'll try if this works. Invalid syntax. So I'll search how you can check the data type of sliced value also. However, you can see here that it is a list. Okay, so you have something called append. Okay, so append is a command if you want to add something here. Okay, so let's say you have to append a value, you have to add one more planet named as Mars. Okay, let's say you have, okay, I have the list name dot append. You have to write append here, and then you have to write the value you have to attempt. Let's say Mars. When I'll print enter, it will execute. And now when I will print the value again, sorry, in the next cell, print name or just name, you see it has already added the value Mars here. Okay, so you have one more thing here, len command. So it actually show you the number of elements contained in that particular list. Okay, so this is how it works. So now let's go to the if else statements, which are known as control statements. Control statements are used a lot again. So control statements are like, if this is true then do this, if this is not true then do this. So if this is something true then do this, or if that another value is true then do this, else do nothing. Okay, so this is the theory part I explained to you in just layman language. So let's write a heading of else. If aleph else statements or control statements. Okay, so yeah, so let's say the temperature is 5000 kelvins, and if temperature, so how the syntax is like, if temperature is greater than 5000, then semicolons, then with a tab space here, then we have to write print hot star. Let's say aleph means or if. Okay, temperature is greater than 3000, and okay, so here we have used and, temperature less than 5000, let's say. here I have written equal to also, so that if it is equal to 5000 it will consider as a whole star. Print moderate star or like just a star. Okay, else print whole star. So when I execute this, temperature is 5000, so it will consider it as hot star. So there is one more thing here now. Let's take it as an input now. Okay, input print temperature or enter temperature. Okay, so when I enter a temperature, let's say 100, and press enter, let's say wait a second, not spotted between the okay, so I have to just mention here that it's an integer, I guess. Now it must work. Yeah, so since we are only taking the integer values, and these type of comparison things work only in the integer or decimal values, so I have to specify that my input will be an integer. Okay, earlier I just wrote input enter temperature, so what it did was it was considering this thing here also as a string, so it was confused that it was a string or an integer. So yeah, so we mentioned that our all quantity will be an integer specific, so temperature was 100, which was below 3000, and it considered it as a cold star. So this is how we can use if else statement. So you can try a different version of if else statement like magnitude and all that stuff. However, we will be covering this a lot when we are working with redshift and spectral work, when we are doing spectral fitting using Gaussian methods. Okay, so we will be working with that in future. So for now it's enough, because you got a knowledge how these things work and how we can implement the control statements, logical operators and comparison operators, logical and comparison operators, right? So now we have something known as loops. Loops are also used, nested loops are also used in astronomy data analysis. So let's work with loops. Loops are of two types: for loop and while loop. Okay, so first discuss the for loop. Okay, when we know the range of numbers or a quantity of data, we use for loop. Let's say we're working with the for loops, so it work like this: for I in range 1 to 10, print I. What is I now? What is I? And what is range? These are some new words, right? So I is basically the in elements in the range 0 to 10, but excluding 10. Okay, okay, so when I will press enter, you see that it has printed everything from 0 1 2 3 4 5 6 7 8 until 9. Okay, so this is how the for loop works when we have a particular range. Okay, so we will get deeper. So the part today we are doing is just an overview for the Python basics. We will be doing complex with the application of astronomy, so that we don't repeat everything again and again. We do some new stuff when we learn something in the next video lectures. So yeah, so these are some of the basic examples. While loop are used but in very complex way, I will be telling you how we can use them. Okay, so we will be using we might be using loops in NumPy also, for loops especially. We use most of the time for loops. While loops are uncontrolled loops also. Okay, so let's say for names, name in name, print names. Now let's say we will simplify this. X X. So you see, the name was actually our list. Okay, just a second. Yeah. So name was actually our list which contain all these values. So what I told him, for X, that is elements in name, print all the elements. So this is how the for loop works. Now let's discuss while loop. While loop must be controlled with specific value. Let's say if we make a, it is a conditional loop basically. Okay, it's a conditional loop. If something is true, then it will work. If something is not true, it will not work. But if something is true, we have to apply a limit to the loop so that it works only to that specific value. Otherwise it will go to infinite values. Okay, so to stop that thing, you have to stop the kernel and you have to rerun whole the code. Okay, so now it is a conditional loop. So let's say the count start from 1. We have to give it a assigned value that you have to count from 1, while count must be less than equal to, let's say, 5, and then semicolon, print count. Now it's again an incomplete syntax. What we have to print is, we have to print 1 plus 1 2, and then 2 plus 1 3, and then 3 plus 1 4. We have to print the forward counting. So to do that, we have to make him understand that you have to print the values by adding 1 in the previous value. Okay, so when I press enter, so it will print 1, then 1 plus 1 2, until 5, because we have applied equal to here, so it will also print 5 here. Let's say I just add 12 value. So okay, so okay, why it has not worked? Okay, so our code is correct, but the limit is still 5. When it tries to add 12 in 1, it give a false value to our condition, so it doesn't work. When I press 2 here, it is valid, so it give all the odd numbers here. So yeah, this is you can play around these while loops, but we will be dealing with the for loop most of the time. Okay, then let's say we have to break a loop at certain point of time. For loop, let's say for I in range 10, if I is exactly equals to 5, break. Okay, so now print I. What I have done here is very important. Then what I have done is, for I in the range of 10, okay, so it will be printing the elements from 0 till 9, including the ninth value. But I have applied a condition that if I is equals to 5, then break the for loop, so it will stop the for loop there only. Okay, and then using backspace out of this if condition, under the for loop I have printed I, and when I will run this, it will only print till 4, because it will not print 5 also. Okay, so this is how we can work around with the for and while loop. Now the main thing here is functions. Functions are very important. Okay, so you might forget everything we have done today, but you must not forget how to deal with functions, how to create a functions, because these are very important in astronomy. So we use a lot while making a pipeline. Okay, so I'll let me show you one pipeline here I created. Hopefully I have that here. Okay, so I have this pipeline here. So you see here, these are some of the libraries I have imported, and then these are the functions here, which is converting magnitude to flux, then flux to magnitude, and all these formulas here. I hope you are able to see this particularly. And then I have loaded the light curves using the functions, and then I have applied these PPC analysis. These are some probability analysis for AGN vectors calculation. So I have done all these steps here. So whole of this pipeline is actually functions. So then I have created a function for plotting the relationships. So these are all the things. So this is a huge code of the whole pipeline. So I'll just quit this code. So functions are very important because we use a lot in astronomy. Okay, so just a second, I have very low battery. Just a second. It's not charging. Okay, anyway that it will work. Okay, so to start with a basic function, so I'll just make a mark down. So to start with the basic function, we have a syntax which is named as define, which is a short form for define. Okay, so def stands for define. Okay, so define, then we have to write a function name, let's say greeting function. We have to greet someone, and then again semicolons, then press enter to the next line, then print welcome in the parentheses always, welcome astronomers. Then nothing happens, right? Because to make the function work, we have to call that function. Okay, so I'll print this greet here. So you see, when I call that function, it says welcome astronomers. Okay, so this is a non-argumented function. It doesn't have any parameter in it. It is independent function. So this is okay, and this is a non-argumented function. It does not have any parameters. It's an independent function. So yeah, so it doesn't have any parameter. Like for example, when you are working for the redshift formula, right? In the redshift formula, you have a dependent value, which is basically the lambda observed value. Okay, so the theoretical value we know, we have the observed value. So that function must be dependent upon two parameters. That will be the lambda theoretical value and the lambda observed value, so that it can grab those both values to find out the redshift value. So that will be the homework for you guys. So you have to create a function which is parameterized for two values for the redshift formula. Okay, so now let's work with a dependent function. That will be a argumented function. that is functions with argument. That will be a redshift function. So I will not be doing a redshift function directly here. It is a task for you guys. So let's say, so I will be doing that tomorrow for you. So I hope let's create a function for now, which is star info, then name here. This is argument which need a name. So let's say print. For argument function we have to use f here, because it will be the formatted, because it will be printing something name also. So the star name is, the name of the star is name, full stop. Now when I will go here, so you can just press tab also here. When you will print tab, you will get these options. You have to either print these of things. So you see the star is I instance, and then we have the function here f. So I'll just press enter, and then I'll in the string I will write serious, let's say, and then shift enter. So you see it says the name of the star is serious. Okay, so this is how it works. So let's say we have to create a mathematical function. Okay, so in which we have to do some calculations. So let's say addition function. Okay, so basically a hint for you guys, the redshift function is a multiple arithmetic operating function. So you will need different arithmetic operations to create a redshift function. So this is only addition function, which will need a parameter a and b, which are the variables, which might be integer, and then here we have to print a plus b, let's say. Yeah, so add 3 and 2, and it's a 5, right? So there is something called, so this is all about functions, basic functions. So today we have learned a very basic thing. Okay, so these are the things you can find anywhere in the internet, right? But when we will be dealing with the astronomical data, these function will look horrible. Okay, it will look deadly to you guys. You will be horrified by looking at these functions, because it will contain a lot many formulas, a lot many algorithms, and all that stuff. So it will be a lot big, the one I showed you, right, in the pipeline. So so yeah, sure. In the stage of AI, you can definitely take help from AI, right, to create those many big functions. But you have to make sure that the formulas the AI is using must be correct, so that it doesn't make any issues in the research output, right? So let's say there is something called return value in function. So you might be noticing that why we are printing this every time, the value might change. So there is something called return value. Return and print are different. Okay, so I'll create a same function. I'll create a same function here. Okay, but here I will just write return without any bracket, a multiplied by b, and then I'll print the same thing here. So, oh sorry, it was an addition function. So you see here what it is doing. So before running that command, right? So basically that what I wanted to show you. The print command does not remember your answer, doesn't remember your values, but in return values, it remember your function and your uh, quantity. Because when I change it to plus sign and it was not saved, and I rerun that code, it again give me the 6 value, because it stored that answer with it. Okay, so return value help us to store that for the long term. Okay, until we assign it a new value, right? So now when I will rerun this, it will be giving us 5. Okay, so this is how the return things work. uh, right. Okay, so what we can do more, we have 15 minutes, right? However, we are covered with basic Python. I don't want to start NumPy today, so I will be giving you some tasks. Okay, you may try those things. You can try out those problems. I will be sharing that also on GitHub repository. I will add you all in the collaborator so that you can get access. So, what we can do more? Okay, let me see. So yeah, I think we are done for today. We are done for today. There are some problems I would like to do right now, but I think that with a little bit knowledge what I have explained, because I have explained very little about functions, very little about loops, but I will be giving you some problems which are way more uh, might be moderate. These are easy. The problems might be moderate to tough to make you see how much you can do with this much knowledge in Python. Okay, so I will be sharing some problems with you. You must try those problems. If you have any doubt, we will discuss in the session. Okay, so or in the Slack server, right? So you can share your doubts there. Other people may help you uh, right, solving those problems. So these are very basic things. We will be going into advanced when we are dealing with the application of astronomy, right? When we have the hand on with the real data of SDSS fits files or other files, right? So we will be creating those big functions. However, I will be sharing these functions, these more problems to you today itself. So now the thing here is uh, we are done with this. Let's say end here. Let's end this here. Delete this. So this is the end. Now what I have to do is, in the day one you see this file here. I'll quit this server from here now. Staying this page, I have to save this now. So I'll quit this. Now what I will do is I'll quit my Jupyter notebook from here. So now uh, I'll use a git command, git add, and then space, then dot. What it will do is, and then when I press enter, it will basically add all the files I have changed, and it will update all the files. And when I will write git status here, you see that it shows new file. It is a checkpoint actually. It's a checkpoint file. It doesn't matter a lot. The main file is day one IPython notebook. So when you are dealing with a normal Python pipeline, it will show you python.py. When you are dealing with the Jupyter notebook file, it will be IPython notebook. So nothing much difference, but it is different with these formats, right? So both contain the Python content. So now you have to add a commit. Commit is basically a push kind of thing, a prior to push, which will show a message. Let's say I'll open that GitHub file. Third agent school. Actually, I also have the content for the second agent school, but as I lost my GitHub ID, I can't share it with you now because I have also lost it from my side. So, but if I get from any of the past students, I will definitely add that content also GitHub repository here also, so that you can assess that also for reference. So you see, this is a comment here that create readme file, but when we have to do a custom comment, this is the, let's say, day one basic Python. Okay, so this is the comment it will show. When I will press enter, it show that two file has been changed. So these are the two files, and now what I will do is git push. Okay, so you can also do /f, which will if there will be some problem, it will forcefully just push the file. Okay, but this is not recommended every time, but because there might be some problem on your side. When I will refresh this, so you see basic Python day 1, it's here. When I will click on this folder, it will show this day 1 IPython notebook, and when it will load, it's 19 KB file. So you see I have uploaded whole file. Now you will be able to uh, work get these access. So to share this private repository with you, I need your GitHub IDs in the Slack. You can share your GitHub ID in the discussion channel, and I will add you from here. Okay, so that you can get the access. Okay, so I will add you as a collaborators, so you can just right. So either give your usernames or the email linked with that username, so that I can get add you. So yeah, so I'll stop the recording here only. So that's for today. Tomorrow we will be discussing about Python libraries. So yeah.